Hi, good morning students. I am Vaishakhi Shah from LJ Institute of Engineering and Technology. Right now we are studying the chapter which is buoyancy and flotation, and we already discussed what is buoyancy, what are the buoyant forces, and a method which is analytical method for determine metacentric height. We already studied Archimedes principle, what is metacenter, what is metacentric height. Okay, so now in today's lecture we are going to study how we can find out metacentric height for any object by using the equation which we derived in analytical method. Okay, so now let's start. Before starting the example, first you have to remember the equation which we derived in analytical method. Analytical method is also called theoretical method. In GTU sometimes ask that explain theoretical method to determine metacentric height. So analytical method or theoretical method, both are the same theories. So here we derive this equation Gm equals to I by V minus Bg, where I, that is moment of inertia of different bodies or different shapes given to you, and here V, that is the volume of body. Remember here volume of body submerged in liquid. Here V is not volume of entire body. Here we are taking V, where V, that is volume of submerged body. We are taking volume of only submerged part, not the volume of entire body. Okay, so now for any example also you have to also remember this conditions, where now let's see here, imagine if there are 3 points here. Okay, if any body is in stable condition, then what is the location of G, B and M? Now here there are two different diagrams where there are 3 different points. Now for stable equilibrium, M should be above G and B. Now if M, here M is your metacenter, G, that is center of gravity, and B, that is center of buoyancy. If G is above B and M is above G, then this body is called in stable equilibrium. Now for unstable equilibrium, if G is above M and above B, B is center of buoyancy, G is center of gravity, and M is metacenter. So this condition is for unstable equilibrium condition. So if in any example, if point A is above G, then it is stable equilibrium. If G is above M, then it is unstable condition. Okay, so let's start with our first example. Here very first data given to you is a rectangular block of 4 meter long, 3 meter wide and 1.2 meter height. The depth of immersion of block is 0.8 meter in sea water. Determine the metacentric height if center of gravity is 0.6 meter above bottom of the block. Is the block is stable equilibrium or not? So in this data, first of all, the shape of body which is given to you is rectangular block. Rectangular block. So here is your rectangular block. Now the dimension of rectangular block, first depth or height of the block, which is 1.2 meter, width of the block is 3 meter. Now if you see this block from top view or from the plan, then you can see the dimension length which is 4 meter. So here remember that for any example of buoyancy chapter, first you have to draw the diagram, and diagram consists of two things, elevation and plan. In plan you are seeing the object from top, and in elevation you are seeing this object from side. Okay, so here in elevation you can see two dimension, first depth or height, second that is width, and in plan you can see the dimension length. So here length of object is 4 meter, width of body is 3 meter, and height of rectangle is 1.2 meter. Now the another thing given to you in data, which is depth of immersion. Now depth of immersion, so total height of block here is 1.2 meter. Now from 1.2 meter height, 0.8 meter height is immersed in water. 0.8 meter height is immersed in water. Okay, so now in the diagram, see this diagram, here we are taking 3 points. At bottom we are considering point, assuming point A. Now next point is B. B is called center of buoyancy, and G is called center of gravity. To find out metacentric height, here we have to find out metacentric height. For to find that height we need all the distance, all the dimension, and we are using the equation GM equals to I by V minus BG. So in this diagram there is point B, there is point G, and there is a bottom point which is A. Now total depth of rectangular body is 1.2 meter. Now in rectangular, at which point there is a center of gravity? It is at h by 2 or d by 2. So in this rectangular diagram, the distance from bottom to center of gravity is 0.6 meter. Okay, so distance between A to G, that is 0.6 meter, that is 1.2 divided by 2, total height divided by 2. Okay, now we have to find out here, we want here BG, the distance between B and G. Okay, so next distance we are finding here, that is AB. Now remember this, at center of rectangular body, total height divided by 2 gives you center of gravity, which is point G, and if you divide immersed height divide by 2, there is a immersed height divided by 2, which gives you center of buoyancy. So here the depth of immersion is 0.8 meter, so 0.8 divided by 2, that is 0.4 meter. So distance between AB, that is 0.4 meter. Remember this clearly. So capital H by 2 gives you AG and small h by 2 gives you AB distance. Okay, so now in this if we are solving this example, then here dimension of the block, that is 4 meter into 3 meter into 1.2 meter, and depth of immersion, that is small h, which is 0.8 meter. This dimension given to you. Now here, as I told, AG, distance between A to center of gravity G, that is 0.6 meter, which is 1.2 divided by 2, and AB, distance of point A to center of buoyancy, that is half of depth of immersion. Half of depth of immersion, that is half into 0.8, which is 0.4 meter. Okay, so here you already have the dimension AG and AB. So you can you get A into so here you get BG by using equation, see in the diagram, AG minus AB. If we are placing AG minus AB, that gives you BG. So Now again this is your diagram, these are the points. Now we have to find out volume of water displaced, which is V. Now volume of water displaced, that is, here remember that consider submerged volume. Here what is the length of body? 4 meter, width of body 3 meter, but total height of block is 1.2 meter and immersed height of block is 0.8 meter. So to find out volume of rectangular block, that is length into width into height, so consider immersed height here. Okay, so total volume of water displaced, or V, that is length, which is 4 meter, width, that is 3 meter, into 0.8, so you get volume 9.6 meter cube. Now we have to find out I, which is moment of inertia. So what is the equation for I for rectangular body? That is B into D cube by 12, BD cube by 12, B, that is 4, D we are taking 3, so 4 into 3 cube divided by 12, that is 9 meter raised to 4. The unit for moment of inertia is meter raised to 4, and equation for rectangular body, that is BD cube by 12. Okay, now BG, as we discussed, BG, that is AG minus AB. We have the value of AG, that is capital H by 2, which is 0.6, minus AB, that is small h by 2, that is 0.4. So your final answer for BG is 0.2 meter. Now here comes the equation of metacentric height, where GM equals to I by V minus BG. Now here we have all the values. I, that is 9 meter raised to 4, V, that is 9.6 meter cube, minus BG, that is 0.2. So your final answer for GM is 0.7375 meter. Now unit of distance, it is a distance, GM, metacentric height, so unit of that is meter. Now here GM is greater than 0, GM which is greater than 0, so M is located above G and the block will be in stable equilibrium because GM greater than 0. So if GM greater than 0, then M is above G, and if M is above G, then body is in stable equilibrium. Okay, so this was the example for rectangular block. Now our next example here, a solid cylinder of diameter 4.5 meter has a height of 3.5 meter. Find the metacentric height of this cylinder when it is floating in water with vertical axis. The specific gravity of cylinder is 0.6. This data is given to you. Now first of all, shape of the body is cylinder. Now in a cylindrical body, imagine a cylindrical body, a pencil. Okay, so if you are seeing a pencil from plan, then you can see a circle. From top view you can see a circle, and from elevation, from side view, you can see a rectangular. So here in plan, the shape you can see, that is circle, and in plan the shape you can see, that is rectangle. So here in diagram we draw two diagrams. First is for plan and second is for elevation. Now top view, that is plan, which is your circular body, and at bottom that is a rectangle. Okay, now what is the diameter of this cylinder? That is 4.5. So as here in as shown in the diagram, diameter is 4.5 meter, height, total height of cylindrical, that is 3.5 meter. Okay. Now, specific gravity of cylindrical is given to you, and that is 0.6. Here in the data, submerged height or immersed height is not given to you. So, remember the equation indicated here. If you want to find out depth of immersion, so the equation for depth of immersion, that is specific gravity into capital H. Specific gravity into capital H. So, here specific gravity of material is given to you, which is 0.6, and capital H, that is your total height, and that is 3.5. So, by using that 0.6 into 3.5, you get immersed height, which is 2.1 meter. 2.1 meter. Now, as we already discussed, AG, that is total height divided by 2, capital H by 2, which is 3.5 divided by 2, and that is 1.75 meter. And AB, that is small h by 2, immersed height divided by 2. So, small h by 2, here small h is 2.1 meter divided by 2, that is 1.05 meter. So, by using these values, you can find out BG, where BG equals to AG minus AB. So, 1.75 minus 1.05, that is 0.7 meter. Okay. Now, we have to find out I, which is your moment of inertia. Now, for circular body, to find out, now also remember this, to find out moment of inertia, consider the shape of body which is in plan. Now, here in plan, the shape of body you can see, that is circular. So, to find out moment of inertia, consider the shape which you can see in plan. So, here you can see circle in plan. So, what is moment of inertia for circular body? That is pi by 64 d raised to 4. Here you have diameter also. So, pi by 64 into 4.5 raised to 4, that is 20.13 meter raised to 4. That is moment of inertia. Now, to find out metacentric height, which is GM. So, GM equals to I by V minus BG. Now, we have all the values. I, that is 20.13, divide by V, that is 33.40, minus 0.7, that is minus 0.1, minus 0.1. Now, here volume, we are taking volume, that is 33.40. So, volume you can find out by pi by 4 d square into small h. Pi by 4 d square, that is area, into small h, which is your 2.1 meter. So, pi by 4 into d square into small h, that is 2.1. So, by using this equation, you can find out volume, and your answer is 33.40. Now, your overall answer for GM is negative here, that is minus 0.1. So, negative sign indicates M is below G. If M is below G, then cylindrical is in unstable equilibrium. So, this here negative sign indicate unstable equilibrium, and if your answer is in negative, then M is below G, that is unstable equilibrium. Okay. So done for the today. Now, you can solve other examples also by using the same equation. Okay, we will discuss some more topics related to this chapter in our upcoming lectures. Okay, goodbye.